And we want to start relating the graphs of the f of x function to the graphs of the f prime function or the derivative function. And again, the idea is the y values of the slope function should reflect the slope values on the original function. Okay, so I've given you two derivatives here. Let's look at the first one, x squared. The derivative works out to be 2x. So here's my original function, x squared. Okay, and we're just going to analyze how we get to the slope function, positive 2x. Okay, so the things that we want to look at, these are the things I want you to make note of. So what's really key is that zero derivative right there, okay, where we have a horizontal tangent. That's very important because that marks a boundary between when the slopes are positive versus negative. That's an important part of the graph. It's a vertex on the graph. So when we analyze these pieces here, I then go to the other part here where I can see where I have positive slope. In fact, the positive slope, and it looks like also the slope is increasing. And so it gives us this section of the derivative graph. Okay, so we're looking for positive y coordinates where we have positive slope. And then we're going to look for negative y coordinates when we have negative slope. So there's my negative slope in this region. So on the derivative graph, we're looking for negative y coordinates. Okay, so we can go from the original function to its derivative function, but we could also go the other way around too. If we can see the parts that match, so if I see positive slope values here and I can see positive increasing slopes here, I can see negative slope values here, and I can see that where it looks like there, we can actually go from the derivative back to the function. And it is important for us to be able to draw these slope charts. So these slope charts are very important for us to analyze these graphs. So slope charts is going to look like this. So I have my f prime values and my x values. So at my x value equals 0, I'm going to have a slope value of 0. Okay, so I'm just going to draw it like that. And where my slopes are positive, okay, so on this section I have positive slope. So I'm going to, in my f prime section, I'm going to show positive slope. I'm going to show it like that. Okay, and then we can see with these little slope segments. So there's my horizontal slope or 0 slope. There's my positive slope. And where my negative slope is here, I'm going to put negative y values, which gives me negative slope values that look like that. And so this slope chart from my slope graph allows me to get back to my original function. Okay, so that allows me to see the shape of that function. That's very important that we understand how to relate these shapes from these graphs. So we can go in this direction from the graph to its derivative. And again, the key things that we're looking for are 0 slopes, where the slopes are positive, where the slopes are negative. The other thing that I added in the notes last day was that we can look at also the relationship of the changes. So the power rule changes. So quadratics differentiate to linear. So if I have a quadratic looking graph, it should differentiate to a linear looking graph. But we can go from the function to its derivative, but we can also go the other way around. So this works both ways. So let's take a look at the cubic function. So there's my cubic function. So again, I'm going to look for the same things. On this cubic function, I'm going to look to see where do I have a horizontal tangent. My horizontal tangent is right there. Okay, that means that my slope is 0 at that point. So I should have a 0 value for slope. Okay, I'm going to look for positive slope sections. So I'm going to look for positive slope sections here. In fact, this graph is always positive. So notice that I have positive slopes in here. I also have positive slopes in this section. So the slope graph is always positive. It is 0 at that one point there. Okay, so but other than that, it's all positive. So again, it's important these are parts that we're looking for. I also want to relate this to the slope chart again. So at x is 0, I have a slope of 0. On the negative side of x, I'm going to have positive slope. Okay, so I'm going to have positive slope that looks like this. At the 0 slope, I'm going to have a horizontal tangent that comes across like this. And then on the other side, my slope is still positive, so it's going to continue to go up in this manner. Okay, so this is what indicates a slide, or if you take a look at our graph here, the original graph, yeah, this slope chart then allows me to have an understanding or a sense of what the original function looks like. Okay, so we're trying to relate these x coordinates to each other, where the slopes are 0. We want that x coordinate, we want to find a y coordinate of 0. Where the slopes are positive, for those x coordinates, we want to find y's that are positive. For the slopes that are negative, we're looking on the slope charts for those x values where the slopes are negative, or the y values on the slope graph are negative. Okay.